So in this lecture, I'm going to go over how to calculate correlation coefficient, that is Pearson, in this case also denoted as a small r, for this given data: serum ionized calcium, that's X variable, and blood pH level respiratory alkalosis, that's Y variable. And I'm going to assume that you already know these formulas for variance of X, variance of Y, covariance, and the main formula for R. So this is like the schematic representation, what we need for R, all of these small parts of the formula that we are going to derive and solve the problem. I'm going to create the sum or total. So that's going to be sum of X here, sum of Y in here. On the other columns, I'm going to get the column for X square, and summation for that will be on the bottom. Y square for each of the Y values, and again the summation will be right here, product and the summation. So now it's pure math, just do addition here on X to get the summation of X. So just add them and it's gonna be 38.2. Similarly, Y summation you can do. That's gonna be 30.8. Now you do X square for individual X value. That means in the first row, we are going to get square for 10.2. So in here is going to be 10.2 the whole square. So I'm going to just write it, the final answer. Similarly, squares for the Y column, individual squares. So first will be 7.5 the whole square, because the first Y value is 7.5. So 7.5 square and then 7.9 square. Eight square, and then 7.4 square. On the bottom, just like X sum and Y sum, we are going to get summation of X square, summation of Y square. So let's do the addition for X square. Now let's do the product of x and y. So just multiply x variable with the y variable for each of those rows. So first in this case is going to be 10.2 times 7.5, and that's going to be answer for this first cell. And that's 76.5. 79. So finally we are going to get the summation. So now we have all the raw materials we need to go into these steps or formulas, right? And ultimately we are going to go substitute all these three entities into one big entity, which is nothing but our final answer. That's correlation coefficient, Pearson in this case. So now it's just pure math, but I just want to show you the steps. So I'm going to solve. Oops. So this variance of x first, 1 upon n. In this case, we know there are 1, 2, 3, 4 data points. So that means our n is 4. So that's why 4 minus 1. Summation of x square. So see, summation of x square, we get it from this value. So that's going to be this value. Then summation of x, the whole term square. So basically we are going to get the summation of x and then square it. Don't confuse this with summation of x square, this one, because that's not correct. And then just simple math, solve it. I'm just rounding the final answer to the second decimal point. That's variance of x. Similarly, we can do variance of variance for y. And we can extract all these values from here. So y square, we have it here, summation of y square. Summation of y, the entire square, that's a different term which is right here. So we are going to square that sum of y. So that's variance of y. And lastly, we are going to calculate covariance between x and y. Summation of xy again is right here, 293.5. Summation of x is 38.2. Make sure you consider that negative value or negative sign, because we are subtracting a larger number from a smaller number here. So don't forget to account negative sign, because your direction of correlation will change otherwise. So our covariance is negative 0.21. So now The final step is just substituting all these three values, variance of x, variance of y, and covariance between x and y, into the final formula for r, that is variance. So we know r, we already saw that r is nothing but covariance of x and y divided by square root of variance of x, variance of y. So that's just the final step. Substitute all those three values as we can see. That's where we got the values from, and you solve it, and in the final answer don't forget that negative sign because that really explains the directionality, right? So our final answer is negative 0.68 Pearson correlation between x and y variable. So that's it. So quick summary of this entire example. So we had this data and all those formulas. Based on that, first step is just to get that table with all the additional columns and the final row. Second step is variance of x. Third is variance of y. Fourth is calculating covariance between x and y. And final step is getting the r using all those components